at a particular slide here. Okay, we talk about fluids part 2. Today we continue this. Tell me, do you have any problem with these? How they work, how you can find it, how to work in this one? Is that okay? And we talk also, if you remember, gentlemen, that alaykum salam wa rahmatullah. This is a manometer. Always, when you say manometer, you just imagine 2 points at the same horizontal level, they have the same pressure. So what you do, oh, this point, and this is a small point here. If you know this height, and you know this height, they are equal. They have equal pressure. So simply you can say, here, pressure 1 is equal to pressure 2. Whatever, this is oil, this is, and this is water, whatever is it. So always be looking for the 2 points of the same horizontal level in that one. Okay. If we proceed after that, we solve this problem. I think we stopped here last week. We solved this problem, right?
Yeah.
If you remember, gentlemen, we start with these 2 points and then we modify this one. I'm going to give you just like as a worksheet some more examples on the manometers. I think next week this will be submitted. Till now, your blackboard is not on my account. لحد الآن ما نزلوكم على حسابي يا شباب. I will give you many problems in these. You can solve it by mentally only. This one is equal to this one. We can add 2, 3, 4 liquids. It's okay. Never mind. You just find where's the common thing and you do that comparison. Okay? This is what I'm saying. No matter what is inside, all the points of the same horizontal level, they have the same pressure. Regardless of the type of the liquid above that, these points. We don't care. This is it. Okay. Now, this is also we talked about it last week. I told you, you just care about 1, 2, and 3. What is the SI unit for the pressure? Pascal. So means, if you have any other unit, you have to convert into Pascal. If I say atmospheric, you just do it just like cross product. 1 atmospheric, see, simply is equal to 101,300 Pascal. So 2.6 atmospheric is equal to X cross product. That's simple. There's no way. Just no way for making any problem with that one. Okay? These don't care about it, I'm sure. Now let's go to the next point. If that's clear for you. First of all, this device, this is the old device that we use to measure the blood pressure. This device contains a mercury inside it. That's why the calibration will be given in millimeter Hg. If I gave you this, oh, this is 800, suppose, millimeter Hg. And in problems, you have to convert it into Pascal. That's simple. As I said, that this is equal 760, for example, millimeter Hg equal 101,300 Pascal. So this is equal X cross product. Okay? Now let me talk about what we have. If you have this calibration for your heart beating, the highest point, gentlemen, here, we call it by, we call it by the systolic pressure. Systolic pressure, بسموه الضغط الانقباضي لما ينقبض القلب. When you simply, your heart contract. Okay? And the lowest point here, or here, by the way, it's called by diastolic pressure. Diastolic pressure, الضغط عليكم السلام الانبساطي. That's simple. Now, for normal people, we have 120/80. Depends on the age sometimes. This is here we have the systolic and this is the the diastolic. Okay? You should know now. Now, any increment above of these, there would be a problem. Today we talk about this also, that if there is more high pressure, I need to tell you something. In the blood vessels, we have very, very delicate and very sensitive blood vessels called capillaries. If the blood increases in the capillaries, في الشعيرات الدموية, suppose inside your eyes, inside your brain, there would be some actually simply losing of these capillaries. They will explode the blood if the pressure increases. And now you have what we call by the internal bleeding, لنزيه داخلي. And this is very risky. You cannot feel this one. Let me tell you something. All the people, if they have this bleeding, internal bleeding in their eyes, in their retina, for example, they cannot feel it, but slowly they will lose their sight. Day by day, they will start losing their sight. Why? Because they're losing the blood, and that blood simply provides all the needs of the cells inside the retina. If the blood stops, there will be no that and supplies, right? So this is important. We care about it. Now, your blood is 120/80. This is, what's the unit of that blood here? What are the units of this measurement? We say it's millimeter Hg on the device. Are these values gauge pressure or absolute? What do you think?
Gauge pressure.
Gauge. Why, Ashbab? I told you from last week, we don't have to measure the absolute. We don't have to measure atmospheric over and over and over. Just we take, yes, the gauge pressure. Why should the patient's arm be held at the same height of the heart? You should put, yes, in the same level of your heart. Why? You cannot, for example, raise your hand or lower it. Explain it.
Same height.
Yes.
Horizontally.
Let me tell you something, guys. That's right. Your arm will be actually the same level of your heart, will be the same. Yeah, just like what we said. All the points, horizontal point, at the same height, they have the same pressure. Let me say something here. Sometimes, if you have a patient and you want to give him some nutrients in his arm, you just suspend that sac upward. إذا كان عندك مريض بدك تعطيه مغذي، وين بنحط المغذي؟ Up. Why? Now the pressure here is more than your patient's blood pressure. So what happened? That here, this material will go inside the body. It has more pressure. Okay? Now, if you donate with your blood, لما تروح تتبرع في الدم, where do you put the sac? Allah يسعدكم. Now, which is bigger now? The patient pressure is more than that. So the blood is easily will flow from there to that sac. Okay? So this is important. In this case, we have to keep it in the same level. So the same level, they have the same. So if you raise your hand, you cannot say, oh, that's not correct. My hand is not on the same level of my heart. Or if you lower it, it's not the same level. You have to keep it on the same level. Okay? طيب. This is the last point. I will explain, and then we proceed. Now, I want to say something important. How we measure the blood pressure for you? By the way, this is an old, traditional way. It's more accurate than nowadays. We have digital equipment and tools. They just put it. But sometimes these digital, really, they have some large, we can say, large scale of mistakes. Now this is much more better. First of all, this is your main blood vessel inside your hand, in your whole arm. Okay? You put this is we call by a cuff. Cuff just like here. We have it here. This cuff simply you tighten your hand. It will compress your blood vessel. Okay? And by using this rubber here, or you start inflating, تبدأ تنفخ فيها، صح؟ It will actually make more and more and more cuff. راح ايش يا شباب تضغط عليها بزيادة. Okay? Now, you have to use the stethoscope, سماعة. In this case, you have to use it. You just put it there. What you have, this is here very small bottom, just open it slowly. افتح شوية يا شباب. انت ضغطت ممكن توصل ضغط احيانا 300. Suppose on the scale. You just lower it. By hearing the sound, what happened? The systolic here, you will hear some sounds, just like small hammering. And at the systolic, you will hear another sounds. And you can judge how much the systolic, the higher, and how much the lower. This is how we use it simply. Of course, this is knowledge that you will get this later, inshallah ta'ala, because this is one of the most important things. All the doctors and who's working in medical field, they must know it. Okay? This is just only what we concern about it. By the way, nobody will ask you how they measure it. Okay? For us, we concern about the physical side of it. This is the idea.
No question in the exam
No,
about
no.
this.
None of the question in the last 5 years, no question on these. Okay? Maybe they will ask you only what is 120? It's systolic, and 180 is diastolic. That's it. Okay, Shabab. Now let us proceed for the next point. I need here today, I hope so we can finish part. Okay, listen to me, all of you. Good. Today we have something more important. I need to explain this here, then you proceed. First of all, today we will talk about description of the fluid. Let me say something. First of all, the fluids, there are actually two types. There's a liquid and gas. Is that right?
Yes.
Okay. I need to explain something for you. See it. We can simply claim that or say that liquids are incompressible. Incompressible here. غير قابل للانضغاط يا شباب. Why? This is because by compressible. What this means? I need to explain because it has significant meaning. Yes.
That means the gases you can easily increase the value and
Change its volume.
Change, yeah.
Perfect. Why the liquids? All the liquids they have definite volume. You cannot, if I give you 1 liter of water, you cannot make it half liter يا شباب. ما بتقدر تضغط الماء صح؟ يعني هذا الماء امامكم والله بدي اضغط وخليه بهالحجم impossible. But the gas in this whole room, you can put it in a small can like this. الغاز ممكن. This is natural. Thank you. So this is first of all, but it has something. Look at me. I'm sorry to have
Okay.
See, so we say that this is incompressible and this is compressible. Okay, this means here, now it has. Now incompressible, we say that it has a constant density. Yes, its density doesn't change. It's keep constant, just like the water. Now here, it has a varying متغير density. Yes, let me explain something. Sometimes we say that density is number of particles per unit area or volume. Since the gas they are moving, sometimes at a particular moment في لحظة معينة ممكن يكون في اليونت اريا 5 جزيئات. في لحظة معينة ممكن يكون 7 صح؟ This is no way. Let me draw it for you. تعالوا. This is my gas and this is my liquid. Liquid we agree about. This is the liquids, right? We draw it last week if you remember. And this is the gases. Let me say something. If you consider only this much, oh, this is 2. The same thing, how much is it? 2. Here, doesn't change. Why here, for example, 1. Here, oh, there is a change, right? So, having here a varying density or changing density, this is we call by compressible, okay? Compressible, that means قابل للانضغام. Now, We sometimes, because I need to explain, we consider liquids as incompressible. And also, I need to say something. We also may consider moving gases also as incompressible. Who can explain why? Moving gases, just like the here, AC ducts here, channels.
الجزيئات بتكون متقاربة، وإذا كانت الجزيئات متقاربة البوند يكون أضعف في الليكويد فيمدي يتحرك معي يكون incompressible.
Yeah, okay. But let me say something.
Could you please repeat?
To make the gases move, you need a pump, right? The pump will push the gases to move. At that time, we can assume that, oh, they have a constant density. Why? Because you still have a pump. They will never move without a pump. Just like the here, air conditioned channels. قنوات التكييف يا شباب. لازم يكون في مروحة تدفع الهواء صح؟ مستحيل تتحرك الهواء لوحده. الهواء لوحده by the way is compressible. لكن لما يكون عندنا moving air we say it's incompressible. We can assume that. نفرض على أساس إنه تقريبا إيش؟ incompressible. You have a question?
أقول إن إذا نفخت البالون يزيد النفخ.
صح. Yeah, this is also an idea. But this is what I mean. So please, Ashraf, look at me. We have fluids, we know that liquids and gases. Liquids we can explain as incompressible because they have a constant density, we cannot change its volume. While the gases, they are compressible because they have varying density, we can change its volume. In a particular special case, we can assume that the incompressible is the liquids and moving gases. Okay, let us go to the next point. We need now, this is just only introduction for today. Let us explain with the flow movement here, the fluid move. What we call this movement, whether the flow walks, or the flow run, or the fluid flow. flows صح؟ يسموه تدفق يا شباب. ما بنقول والله الهواء يركض أو الهواء يمشي صح؟ نقول يتدفق الهواء. Right. Okay, sure. I'm going to say that movement of fluid we call by fluid flow. Pay attention. انتبهوا معي بقى. The flow of fluids also classified into two categories. Here, flow of fluids. في عندنا نوعين من الاشياء. There's something called by laminar. I'll explain for you as something called by turbulent. This is very important now. And I will tell you how they related. Laminar نسميه انسيابي يا شباب. All the fluid layers, they are fluid move smoothly, slowly, and there is no mixing between the parts of the fluid. طبقاته ما تتداخل مع بعضها يا شباب. Just like, for example, imagine, see, this is your pipe as an example. You have a pipe or whatever is it, and the fluid is moving actually in this side. All the lines, see, they are almost parallel like this. They are moving in one direction. Consider this just like your blood. Okay? This is here. Now, in turbulent, turbulent بنسموه اضطرابي يا شباب، مضطرب. See what's happening. They are moving randomly. See, this is like this. Like this down. So let me explain this for you again. The flow of fluid can be classified as either laminar or turbulent. Laminar, see يا شباب, where the speed is slow. This is first of all. Speed is low. Is moving actually smoothly. بكل مرونة بمشي. There is no mixing of layers. طبقات يا شباب. This layer 1, layer 2, layer 3, 4, 5, and 6. There is no mixing. ما تداخل مع بعض. There is no eddies. ما في له زوائد يا شباب. I will explain this later. Okay? Now this is. Let's go to the turbulent. First of all, speed is high. تكون سرعته عالية. Actually move randomly. Randomly عشوائي شباب. We cannot predict. ما بنعرف وين راح يروح. الآن mixing of layers. راح يكون في عندنا شوف التداخل صح؟ طبقات and there is eddies. Let me give you an example. If we have two equal cups of water and honey, and we pour both of them on the table in front of you, we say that which one is gonna wet your clothes? مين راح يبل الملابس؟ الله يسلمك. هذا بس because of eddies. هذه اللي هي يا شباب انه ايش؟ بيسبب تبليل. انه يصير احنا نقولها بالشامي ينطرش. يصير ايش؟ يطرش انتم بتقولوها او ينطرش ما بعرف ايش it's very close. اوكي؟ طيب. طشر هذه في العراق مطشر بسموها. طيب this is what we say. This is an idea. Now first of all, second thing, see يا شباب. If you see there is a line, smooth line of honey is moving and the honey starts accumulating. يبدأ يتجمع فوق بعضه صح؟ Just like that, all of us we know it. احنا نحط الملعقة في العسل نحطها على السندويشة. طالع ظلك ايش؟ هي تتشكل صح؟ In case of water we don't have this case. We have. Now we can assume that the flow of honey is a laminar while the flow of water is turbulent. I need to tell you something. Why we study this? You should make sure that your patient's blood is which one of them? Laminar. لازم يا ابني الله يرضى عليك. Why? Because when the blood flow is laminar, that means moving smoothly and your patient has no problem. He has nothing problem. Why? If there's some obstacles in front of the blood, في عوائق قدام the blood, there will be some turbulence. And your job is to eliminate these obstacles. Let me explain this for you. خلينا أوضح لكم حاجة. شوفوا يا شباب. Suppose we have a blood stream. عندنا احنا زي أشبه بجدول الماء. The water is moving like this smoothly. تعرفوا هذا الشيء. طيب أقول لكم حاجة. If we put here a piece of rock. حطيت أنت هنا قطعة صخرة. إيش بصير؟ بصير move like this. صح ولا لا؟ So this type is laminar and this type is turbulent. Agree about it. كلنا شفنا هذا الشيء. طيب. This is your blood vessel. يا شباب. Sometimes due to our diet we have an accumulation of cholesterol and what we call by tri-fat دهون الثلاثية. These they will accumulate on the inner surface of your blood vessels. هنا بصير تترسب. اوكي؟ من اكل البرجر، اكل الجبن، الشدر هذه صح؟ So what happened? Now this is your blood. Your blood, what happened here? Oh, there's a problem, right? That says here, and then there will be here. What is actually the impact on your patient?
Increasing pressure.
Yes, increasing pressure. He cannot do any physical activities. لو يصعد السلم يصير يلاهث يا شباب. طب شاب هذا يصير يلاهث من السلم درجتين أو ثلاثة. شايفين يا شباب؟ There is a problem. You can't predict. طبعا here your classmate he mentioned there will be more blood pressure. راح يرتفع ضغط الدم يا شباب. So your job is to do what? You are as a physician. إن شاء الله تعالوا تكونوا أنتم معالجين. You have to remove this one. One of the strategies that we use it with young people, just like you, شباب, you just do exercise. تخيل الله يرضى عليكم شباب. When you exercise, لما تتدربوا, your heart beating start increase. Now, when your blood pressure increases or heart, what happens? It will simply clean all these. زي يا شباب. يعني عفوا لو كان في وسخ على الأرض. إذا سلط عليه ماء ضعيف ما راح يروح. سلط عليه ماء قوي. لما تلعب رياضة بصير دمك قوي. ففي طريق الكوليسترول إيش بيسوي فيه؟ يسحبه. طيب, somebody else just like me, I'm an old man, I cannot do exercise. So what we do يا شباب here, in that case, you have what we call here a minor surgery for cleaning these extra cholesterol in your blood vessels. واللي هي عملية القسطرة يا شباب. بيجي الطبيب عفوا يعني بدون مبالغة عنده زي this is eraser بدخل انبوب بالون ايش بيسوي؟ بنظف. زي عندك بايب مثلا مسكر تحط فيه شيء وتمشيه صح؟ نفس الحاجه هو بيعمل طبعا medically طبيا. He just simply do it. طبعا this is very good for us. I'm not saying this is for all people. For young people just like you, they have to do exercise. Instead of doing this يا شباب, when you do your exercise daily, you make the exercises just like a habit of your life. اعملها روتين في حياتك. You will have no problem with that. إن شاء الله تعالى. Okay? طيب. So again, Allah is it. We have two types of fluid. We have a laminar, we have turbulent. We say laminar, the speed is very low. Never mind, we don't care here. It's moving smoothly, there is no obstacles, ما في عوائق, no mixing flares, no eddies. Here, speed is high, blah blah. Okay? Now, if you want to explain also something more, see you can say the lines they are parallel and straight. Here the lines they are random. صح؟ الله يبارك. Now let me say something more for you. Of course, as I said, we concern about this one. There are many things you will study. Now, after that, we take the laminar and here. We need to know something more about here the flow fluids. Flow fluid also is related to the area. Sometimes, if you have small blood vessels and large blood vessel, suppose like this, you see that area here is different than area here.
Higher pressure.
Yes. So what we say, we can say this is area 1 and this is area 2. You will notice something, Vishwa, for you. Let me introduce this. I'm sure that you have this before. We have something called simply volume flow rate, معدل التدفق الحجمي. It means simply, it's logically, منطقيا, what goes in should goes out in the same time interval. في نفس الفترة الزمنية اللي بيدخل لازم ايش؟ يخرج. يعني شباب إذا دخل for example 5 لتر per minute لازم يخرج 5 لتر per. تخيل يا شباب عندك في البيت اللي هو هوز الماء. أنت مشغل. ما في خزانات في الهوز حتى يخب المية. إذا دخل في الهوز من طرفه من عند الحنفية هذه 5 لتر كل ثانية بده يخرج من هناك إيش؟ صح؟ This is natural. This is a natural. So this is we have it here, Shabab, simple. So to introduce this for you, let me explain a little bit. See, there is something we call by volume flow rate. Volume flow rate. معدل التدفق الحجمي. Volume flow rate have this simple. It's simple. It's volume over time. Can I say, you know this word rate means what?
Yes.
Over time. معدل زمني صح؟ Volume flow rate معدل التدفق الحجمي. We have it. Okay. So we can say Q is equal to volume over time. Q is measured in meter cube per second. According to this. I need to explain a little bit. See. Q is equal to volume over time. Can I say the following? Volume itself can be written as area times length over time. بعرف هاي راح توقفون فيها دائما. انتبهوا معي يا شباب. This room has 3 dimensions. هذه الغرفة في عندها 3 أبعاد صح؟ The longest side is called length. الطول. طب المساحة ايش بتساوي؟ length times width. طول في العرض. طب والحجم؟ طول في العرض؟ طب ممكن اقول الحجم يساوي المساحة ضرب الارتفاع؟ صح ولا لا؟
صح.
This is what we do. Area times عرفت؟ This is volume. هذا حجم. الحجم ايش يساوي؟ Area times length. Okay, follow with me يا شباب. This is length and over time. This is distance over time. It is nothing but speed. هذه الآن يا شباب. This is area and this is speed. Oh, what this means? Wow. It means here that more area will be less and more speed will be less. This is, for example, this is your water hose. If you just leave it alone, it will move like this. If you press on it, إذا ضغطت عليه بإصبعك هنا يا شباب. Yes, إذا ضغطت عليه راح يقول إيش؟ مش إحنا بنشوفه بنغسل السيارة؟ والله بدي أوصل ماء إلى آخر الغرفة بس أضغط عليه. صح؟ What we do simply here. قللنا الاريا، ايش صار في السبيد؟ زادت. اوكي بارك الله فيكم. طيب خلينا نكمل بس just this is the last point here. So simply we can say we have Q is equal to V over T. V capital هذه الفوليوم or equal A times V. This is recorded by volume flow rate. تدفق حجم. And according to the equation of continuity في عندنا معادلة اسمها معادلة الاستمرار. ايش بنقول معادلة الاستمرار؟ سهلة جدا الآن تكلمنا عنها. It says that Qn should equal Q out. يعني شباب اللي يدخل لازم يساوي اللي يطلع. طيب تعالوا معي. So what we say we can write in A1 V1 لازم يساوي ايش؟ مر عليكم هذا القانون من قبل؟ صح مر عليكم صح؟ انه مساحة ضرب السرعة يساوي مساحة ضرب السرعة. لازم تنتبه يا شباب، المساحة الكبيرة السرعة ايش بتكون؟ أقل، عكس بعضهم. راح أعطيكم حاجة something more simple for you. See يا شباب. We deal with blood vessels. احنا دائما نتعامل مع اللي هو أوعية الدم. So the area for blood vessel is cylindrical. هو أسطواني الشكل. مساحة تساوي باي R squared. اوكي؟ R square here يا شباب مقصود فيه R هي الراديوس. نصف القطر. فاحنا ممكن لو نكتب هنا بدل area 1 نكتب باي R1 square V1 is equal to باي R2 square V. ايش راح تسوي الباي مع الباي؟ خلاص نكتبها على طول كده. R1 square في V يساوي R2 square في V. طبعا this is to save some time for you. But this is here very important. طيب تعالوا معي الآن. If that's okay, let us proceed. المحاضرة. Okay. First of all, I need to say, we have something called by ideal fluid model. You studied in the chemistry of something called by the ideal gas, right? تذكرون في قانون اللي هو BV is equal to nRT for the ideal gas.
Yeah.
My question is whether there is an ideal gas.
No.
في شيء عندنا شيء اسمه ideal gas. في
No.
لازم مثال عندنا.
لا.
أعطيني إياه وينه؟ ما في يا شباب ما في. طيب why we study the ideal gas؟
نقيس كل معيار نفسه.
نقيس
كل معيار معين.
الله يبارك فيك. This is what I'm looking for. هذا هو يا شباب. When I say when we have ideal gas, we compare our gases to that gas. How they are ideality يعني كم مقدارهم مثاليين. طب أعطيكم حاجة أذكرها دون تشبيه طبعا. For us as a human, we have an ideal person, which is our Prophet Muhammad sallallahu alaihi wasallam. He's an ideal, not from me, from Allah subhanahu wa ta'ala. My question, whether all of us we have the same ideality?
No.
مثلا هاي بيننا وبين ربنا يعني شوف. Some people they have 60, 70%. تلاقيه شيخ مطوع ما شاء الله عليه. وواحد مثلا زينا احنا معظمنا مقصرين تلاقي مثلا 30 40. احنا ما ندخل يا شباب الجنه الا برحمه ربنا ترى من العلم يعني مهما عملنا. صح ولا لا؟ لكن let's say we have an ideal which is our Muhammad, Prophet Muhammad sallallahu alaihi wasallam, and we are talking about all of us we have different ideality. احنا عندنا يا شباب في احد منا بيحافظ على الصلاه اكثر من غيره، في احد بيتصدق اكثر من غيره، في احد مثلا بزور المرضى اكثر. هذه هي صح؟ بس ولا واحد فينا وصل لما وصل له ايش؟ our perfect. Same thing in the same value. نفس النقاش يا شباب. we have ideal fluid. It does not exist. But we try to make our fluid closer to the ideal. اصلا انت ليش لما تعمل your patient blood laminar يعني ايش؟ close to the ideal. لما تتخلص من الكوليسترول عشان تعمل close to ideal. Okay? So there is something called the ideal fluid model to compare our fluid with that one. Let's proceed. What is the fluid is incompressible? We say that density of the fluid remains constant, as we say. Now, it holds for also moving gases. Laminar flow, the fluid velocity does not fluctuate, لا تتذبذب, or change with time at any given point. We say that speed is slow and smoothly. ما في تغير. No loud change in it. Now, here the fluid velocity fluctuate or change with time. This is randomly, as we mentioned here. Let me show you something. By the way, Shabab, I intentionally, just a minute, follow that. Everything I get for you here or here, it's only to support each other. عشان حتى يا شباب ندعم ايش؟ إجاباتنا. See you later. Now, in this picture, these we could almost consider them as laminar. These, that's it. طيب. Now, we have something to talk about it. I'm sorry I just missed it here, but it's simple. We have something called, for fluids, called like viscosity. In Arabic, we call it here لزوجة. Okay? Pay attention. In solids, we have friction between the different solids when they come in contact with each other. الأجسام الجامدة يا شباب أو الصلبة لما تتواصل مع بعضها في بينها احتكاك. In fluids we don't have friction, we have viscosity. Viscosity simply is resistance to flow. مقاومة التدفق. Resistance to flow. Oh, طيب, if we say now more viscous fluids, they will move slowly, just like honey. Less viscous fluids, they will move fastly, just like water. Your patient blood should be less viscous. That's why all the doctors and physicians, they are very actually here interested in the sugar level in the blood, here, in the blood of your patients. Why? Imagine this one, Shabab. If the sugar level increases for diabetic, مصابين بالسكر. أيوة, viscosity will increase. يعني تخيل يا شباب لو أنت سكبت هنا مية مع سكر على الطاولة مش بتدبق بتصير تدبق تصير تلزق. طيب تخيل هذه اللي تصير تمشي في عروق الإنسان. High blood pressure, sugar level. We have a problem. So your job is to do what? To control this sugar level in your patient. من أكثر الآن أمراض انتشارا في العالم كله هو الدايابيتيك، السكر يا شباب، صح؟ Why it is important? Your job is to lower the viscosity. ده السبب الطبيب دائما بيعرض على المريض يقول له I'm going to give you some tablets first. إذا شاف مثلا المريض ما استجاب يصير يعطيه إبر حقن أنسولين. لازم يجبره يخفف إيش؟ طبعا يا شباب consequences consequences بتكون عالية جدا. إنه السكر هذا flow with the blood. البلد بوصل لكل جسمك. بوصل للعين وللأذن للأنف لكل مكان في جسمك. So you start losing your all vital organs. هذا بصير يا شباب. له آثار يعني هائلة جدا على الجسم. Okay? So this is here. We can say يا شباب again. Fluid is not here. The fluid is non-viscous. What is the difference between water flow and honey? We know that. Water flow easily because it's less viscous, and honey is more viscous. Viscosity is the resistance of flow. Now more about viscosity. But we said that the fluid is non-viscous. Sometimes we can assume that the ideal fluid is non-viscous. But does that exist? No. ممكن نقول والله يا شباب احنا عندنا سائل ما في لزوجة بالمرة، ما في احتكاك بين طبقات بالمرة. Impossible. يعني اقول لكم حاجه في الساينس انتم درستوا لما يسقط الجسم الان زي هذا الماركر في له جرافيتي بتدفعه صح؟ طب تعرف انه في عنده فورس اوف فريكشن طيب تقدر تقيسها؟ صعب. تعتمد على شكله، تعتمد على سرعه الهواء وعلى درجه الحراره صح؟ في اشياء في الساينس يا شباب simply we can't simply assume it does not exist. في مكان في العالم ما في فريكشن؟ مستحيل مستحيل. صدقني ايش ما يعني في عالم اذكرها قصه بسيطه اسمه غاليليو، هذا العالم الايطالي. جاء قطعه صابون شباب مبلله، حط على لوح زجاج، شوف قطعه صابون، دفعها دفعه بسيطه. كيف تتوقع الاحتكاك بيناتهم؟ قليل جدا. ومشت القطعه لفتره مسافه ما ثم بعدها ايش؟ ليش؟ في احتكاك. يعني you cannot say claim that there is no friction. In the same manner نفس الطريقه you cannot say there is no viscosity. ما في يا شباب ما مثلا السائل ما في ايش؟ viscosity. عرفت علي بارك الله فيك؟ طيب okay. Let me say something. Now we almost done. إن شاء الله ما في أي شيء. Now we have here equation of continuity. راح أذكركم حاجة. See شباب. I'm not going to use this one. See, A1 to D1 is equal to what? A2. This is we say the volume of here of flow rate is for the bottom. What goes in should goes out. This more area, less speed. This less area, more natural. تعالوا معي هنا. Look at the nozzle here. طلع على الفوة هنا. More area, less. هنا less area, more. طيب انتبهوا معي يا شباب. Look at the water here and at the water here. Who can justify it? مين يقول لي ليش صار كذا؟
قل مساحة المقطع نفسه، مساحة الماء.
طب ليش قلت؟
مع انها تنزل تفرق اذا نفسه.
بس راح
طيب فكروا انا خذ راحتك تفضل ايش؟ increase. طيب لا في شغله اسهل.
كل ما بعدت عن المسافه يصغر حجمها.
طب ليه؟ ما هي هذا. طب اقول لكم حاجه، هذه هي يا شباب هنا سرعتها الان خرجت من الماء صح؟ الجاذبيه ايش تسوي فيها؟ تزيد سرعتها، لما تزيد سرعتها ايش يصير فيها؟ تصير اقل سماحه صح؟ قليله، كل ما طبعا هنا كانت يعني هو زميلها مور يا شباب. اتس inversely يعني عن طريقه مباشره. انتبهوا more speed less area. طيب more area less speed. اقول لكم حاجه، مين سرعته اكثر؟ هذه سقطت من الفوهه، هذه سرعتها اكثر من هذه. due to the gravity صح؟ فراح تكون هذه اقل بينما هذه ايش بتكون؟ اكثر. natural. You say more speed عفوا هنا. We say more speed less area. اوكي بارك الله فيكم. طيب انتبهوا معي يا شباب. This is the most important. We have a queue. تفضل.
دكتور الحين الماء من تحت يكون اسرع؟
طبعا الماء لما خرج من هنا ركز معي بس. تخيل انت قطرة الماء هذه مثلا في اللحظة، تخيل سلو موشن. اللحظة هذه سقطت خرجت من فوهة الحنفية. بعد شوي ايش يصير في الجاذبية؟ تشدها. الجاذبية 10 يعني كل ثانية تزيد سرعتها بمقدار 10 صح؟ يعني كانت هنا سرعتها مثلا 0 بعد ثانية صار سرعتها كم؟
10
بعد ثانية تهدى صح؟ طب إذا زادت السبيد إيش يصير في الأريا؟ ولاحظ النويز صح؟ لسه نشوف. طيب is it clear for you يا شباب؟ واضح؟ بارك الله فيكم. خلينا نكمل مسألة الحال. انتبهوا معي بارك الله. We explain this one. Q is equal to delta V over T, or V over T is equal to A times V. V here is the speed and here A is area. Okay? بعطيكم حاجة بسيطة. والله هذا السؤال يتكرر تقريبا سنويا. سهل جدا. Let me tell you something. The figure shows one flow rate of all but one tube. What is the flow rate throughout the unnamed tube is the flow direction is in or out. احنا عندنا equation of continuity. معادلة الاستمرار هذه claim that Qn should equal Q. الشباب اللي بيدخل لازم ايش؟ بس باختصار تعالوا معي هنا. Qn اللي داخل يا شباب عندك هذا صح؟ وهذا وهذا صح؟ كم مجموعهم؟ Q out اجمع معي 8 و4 12. إذا حتى لازم يكونوا متساويين هذول. إذا هنا لازم يكون ايش؟ إذا هذا لازم يكون out ايش مقداره؟ هذا بدون مبالغة السؤال هذا يا شباب أجى كثير مرات. عرفت علي بارك الله فيكم؟ طيب تفضل.
الآن الوحدة حقت الكيو
بدون كير. لا الوحدة هي متر كيوب بير سكند.
وهنا نحط سنتيمتر.
لا هنا ما ذكر الوحدات هنا بس قلنا أرقام.
لا بس الأساسية عشان وجوب ثاني.
لا الأساسية هذه متر كيوب بير سكند. أوكي بارك الله فيك. راح أعطيك معنا. طيب I have something important. انتبهوا معي يا شباب. One of the years في أحد السنوات جابوا كالتالي. وأنا عاوزكم تنتبهوا. We have a blood vessel, large blood vessel, just like the aorta artery. It splits into 20 different blood capillaries. 20 artery. فوزع هذا ل 20 يا شباب كابيلاري شعيرة دموية متساوية من 1 إلى
تتقسم.
راح أقول لكم حاجة. This is M and these out. ممكن يطلبوا لنا في الحال هذا. Normally what we say يا شباب we say إحنا QN Q out. طيب QN يا شباب we have suppose إحنا عندنا A1 وهنا B1. أوكي؟ هنا إيش يسوي؟
مضروبة في 20.
أيوه أنا هذا اللي بدي إياه. ما في داعي تجمعهم 20 مرة يا شباب. ما في، ما دام نفس بعض اضربهم في كم؟
20.
لو كانوا 10 اضربهم في 10، لو كانوا 5 انت بس بتقول الله يسعدكم اكتب هذه A2 B2 فبتكتب شرط 20 A2 times B2. والله هذا اجى مرة في سنة من السنوات. طبعا ايش المطلوب منك؟ انه يعطيك يطلب يا B1 او B2 او A1 او A2 اللي انتم عارفين. بس ناتشرال. اوكي بارك الله فيكم. طيب طيب خلونا بس نحل السؤالين هذول بعدين في مسألة راح احلها next time ان شاء الله. سير According to the question, liquid of negligible viscosity flows through the pipe shown. Rank in order from largest to smallest the flow speed at point 1 to 4. راح تيجي ترى يا شباب 2 و3 نفس بعض نفس السماكة. أنا عارفكم أنا زيكم فكرت في الأول إنهم مختلفين. فيلا قول مين أسرع واحد؟ بارك الله. ثم 2 و3 زي بعض. ثم أبغاكم تكتبوا يا شباب. V is always inverse to A. بس هذا اللي بدي إياه. وراح أكتبها بطريقة ثانية. V is inversely to the R square. إذا تلاعب معك. يعني إذا R doubled V يا شباب بتزيد ل4 أضعاف. عرفت علي بارك الله فيك؟ ما بزيد لضعفين. لأنه R square. صح؟ This is an idea. You just take care of it. عرفت علي بارك الله فيكم؟ Again راح أوضحها. Speed is inversely proportional to the area. That's natural. We know more area, less speed, more area, just like that. Now, since area, we are dealing with the cylindrical forms, blood vessels. We know that area is pi r squared. Pi is constant, doesn't change. So we can claim that here the speed is proportional to the inverse proportional to r squared. مربع نصف القطر. So if r squared doubled, انت ايش بتحط هنا يا شباب؟ You just say, oh, if this is r squared double يعني تحط 2r squared. 2r squared كم بتصير يا شباب؟ 4r squared صح؟ حتى يتوعد هنا ايش لازم يصير عند السبيد؟ 4r. مش 2 4. واضحة بارك الله فيكم؟ طيب. The last point and we stop. Here طبعا لا تخافوا يا شباب. Later we have a lot of comparisons. عندنا راح تقارن يا شباب بين السرعة والضغط والسرعة والأشياء ثانية راح أتكلم راح أعمل لكم إياها أشبه بتيبل توضح لكم كل هذه الأمور إن شاء الله تعالى. بس الآن سهلة الآن تعتبر السبيد والاريا والراديوس معروفين سهل. Now انتبهوا معي. This is typical question. هذا سؤال تقليدي. وأنا أتوقع دائما. Suppose a syringe is being used to squirt water as shown in the figure. The water is ejected from the nozzle at 10 meters per second. Here. هذه يا شباب called V2. راح نسميه هنا V1. Okay. At what speed is the plunger? Plunger هو اللي يا شباب المكبس هذا اللي نضغط فيه على الإبرة. Of the syringe being depressed. We have a problem. Just that simple problem. This is centimeter and this is. Of course, I advise you here. See يا شباب. If both the same, you can keep them as it is. إذا كانوا زي بعض خليهم زي ما هم. عارف ليش؟ إنك أنت إيش راح تقسم هذا على 100 والطرف هذا على 100 يروحوا مع بعض. ما في. بس هنا مختلفين. لازم تحول. أنا بقول لك راح أقول لكم حاجة بسيطة. تحويل دائما صح. تكسر عين أي واحد لما تحول. ما حد يقدر يقول لك غلط. لكن أقول لك صرت الظن أحول ولا ما أحول؟ لا، هذه أحيانا تغلط فيها. زي هنا مثلا. فأنا أقول لكم حاجة راح أكتب الجواب على طول. R1 square V1 is equal to R2 square. ما في داعي تكتب A1 A2 معروفة. R1 كم يا شباب عندنا؟
1 سنتيمتر.
بدي أحول المتر.
0.01.
وهذا
0.001.
الله يسعدك. That's it. 0.01 square times V1 is equal to 0.001 all square